Okay, so just for these last couple of problems, Josh wanted to measure the height of a Sears Tower in Chicago. He used a 12-foot light pole, so I'm going to stop right there and I'm going to draw it, and measured its shadow at 1 p.m. The time isn't really relevant. The length of the shadow is 2 feet. So you can draw it as a triangle, whatever, but that just kind of gives us a good picture. Then he measured the length of the Sears Tower shadow, so we have this huge Sears Tower shadow, and the shadow is 242 feet at the same time. So the time doesn't matter, it just matters that it's at the same time. What is the height of the Sears Tower? So here we go, we're all in feet, we're good. And so now we're going to set up a proportion. We're all in the same units. So we're going to go, and you can do this either way. You can go 12 over 2 or 12 over x. I'm going to pretend like we have this scale factor of 2 to 242, which would be 12 over x. And like I said, you could have done 12 over 2 equals x over 242. And you're going to cross multiply and solve. And when you do, you get 1452 feet. Really tall building, which we know the Sears Tower is. So perfect. And then check your progress. I want you to pause and work this and then come back. Okay, so first of all, I need all the same units. And so I drew my big green triangle here, my big blue triangle. They're all in feet, but these are feet and inches. Remember, there's 12 inches in a foot. So I call that 5.5 because 6 is half of 12 and 1.5 and then 53.5. Set them up here, set up the ratio, cross multiplied, solve, rounded. Don't forget your units, okay? If they're not in the same units, you can multiply. Remember, there's 12 inches in a foot. Okay. Oh, actually, what I want you to do is I want you to pause and fill in the next two questions and then check yourself, and then you're finished. Okay, so if you fill them in, the three ways to prove triangles are similar are AA, SSS, and SAS. With AA, two pairs of angles have to be congruent. With SSS, all sides have to be proportional, which means you'll have three scale factors that are the same. With SAS, you'll have two sides proportional, which means they'll have the same scale factor, and the included angle is going to be congruent. So those are the only three ways that you can prove triangles similar. And if triangles are similar, that means all angles are congruent and all sides are proportional. If you know this right here, you're doing good. You know what's going on. So now you can stop. Video's over and do your homework, and then you'll take your daily.